Welcome to the Deep Dive, where we take a stack of sources, dive deep, and pull out the most important insights just for you. Today, we're tackling something that touches the lives of billions every single day. Coffee.
Coffee.
But we're looking at it through a specific lens, its surprising and, well, pretty complex relationship with perhaps the most universal human desire, living longer, and, crucially, living healthier as we age.
That's right. The aspiration to increase lifespan, to simply add more years to our lives, is ancient. But as the sources we've dived into for this episode point out, especially in Western countries, just increasing lifespan often comes with a significant catch. They introduce this concept they call the longevity trap.
The longevity trap. I like that term. It sounds like something you don't want to fall into. What do they mean by it?
Exactly. It's the idea that you might indeed live longer than previous generations, but those extra years can be severely limited by chronic diseases. These aren't necessarily the things that kill you outright, but they rob you of independence and quality of life. Our sources list them out: stroke, cardiovascular diseases, various cancers, neurodegenerative conditions like Alzheimer's and other dementias, COPD, physical frailty.
Wow, quite a list.
Worsening sleep quality, sensory decline, depression, difficulties with decision-making. It's quite the burden.
So these are the conditions that often define our experience of aging. They're the major predictors, and in many cases, the underlying causes of death, even if the death certificate just says extreme age.
Precisely. And this highlights why the real goal shouldn't be just lifespan, the number of years, but health span.
Health span.
Right. That's maintaining sustained health, full autonomy, and a high quality of life for as long as possible. And the fundamental challenge here is that aging itself, well, aging is the single biggest predictor and risk factor for developing all these conditions that shorten our health span.
So the natural aging process makes us more vulnerable to falling into this trap. And while researchers look for ways to slow down aging or treat these specific diseases, billions of us engage in a daily ritual that these sources suggest might be relevant: drinking coffee. It's a beverage with a long, often contradictory reputation regarding health.
It is. Depending on when you read or who you listen to, coffee has been everything from a dangerous vice to a health elixir. So our mission in this deep dive, guided by the stack of research and analysis you've provided, is to explore the latest findings on the connections between regular coffee consumption and healthy aging, health span, and overall longevity.
So what do these sources tell us about whether our daily coffee habit can actually help us navigate or even partially escape this longevity trap?
That's the question we're digging into.
Let's unpack that. To even begin to understand coffee's potential impact, we have to appreciate its complexity. It's far more than just its most famous compound.
Absolutely. The sources emphasize that coffee is an incredibly complex mix, containing over 2,000 potentially bioactive substances.
2,000. Seriously.
Think about that 2,000.
That's astounding. We think of a simple bean, but it's a chemical factory. Which of these 2,000 plus substances do the sources highlight as potentially important for health?
Well, they draw attention to several key players beyond just caffeine. There are chlorogenic acids, a major group of polyphenols.
Okay, polyphenols, heard of those.
And melanoidins, which are formed during roasting. Also to terpenes like caffeistol and kawil and trigonelin. Quite a few key ones.
Melanoidins sound dark. Like melanin, what role might they play?
Yeah, melanoidins are those complex brown pigments that give roasted coffee its color and aroma. The sources propose they may have a range of beneficial activities, including antioxidant, antimicrobial, anti-inflammatory, antihypertensive, meaning potentially lowering blood pressure.
Interesting.
And even prebiotic effects.
Prebiotic, like feeding the good bacteria in your gut. That's an angle I hadn't considered for coffee. What about the chlorogenic acids, CGAs?
CGAs are a major class of polyphenols found in abundance in coffee beans. They're widely studied and often linked to antioxidant activity, a common property of polyphenols.
Right.
But the sources list other proposed effects. They can act as anti-inflammatory agents by inhibiting key pathways, like TLR4-mediated NF-chi, essentially dampening certain inflammatory signals in cells.
Okay. Anti-inflammatory.
They're also thought to influence cell signaling pathways related to differentiation, regulate metabolic pathways like AMPK, a master regulator of energy in cells.
AMPK, right?
Potentially modulate immune responses and influence lipid and carbohydrate metabolism. So quite a range of potential actions.
So they sound relevant to both inflammation and metabolic health, which are core issues in aging. But the sources also inject a note of caution or nuance regarding CGAs, right?
They do. Coffee is a very significant source of polyphenols in Western diets, contributing up to 40% of total estimated intake, according to the sources.
40%, that's a lot.
It is. However, polyphenols are present in many other foods, like fruits, vegetables, and tea. This raises a valid scientific question. Are the observed health effects of coffee truly attributable primarily to its CGA content? Or is it something else, a synergy of multiple compounds, or maybe effects that are also gained from other polyphenol-rich foods?
Yeah, that makes sense. It's hard to isolate one compound.
It's really hard to isolate the impacts of just one type of polyphenol when the diet is varied.
That's a fair point. It's likely a team effort, or maybe the impact is compound-specific, depending on the outcome. And while these other compounds are clearly important and contribute to coffee's effects, there's one substance that's almost synonymous with coffee and its perceived health impacts.
And that is, of course, caffeine.
Right.
Our sources confirm that coffee is the main source of dietary caffeine in Western diets. And this is especially true for older adults, where it accounts for over 90% of their total caffeine intake.
Okay, caffeine. We all know the immediate effect that boost, that feeling of being more awake and alert. Traditionally, in biology class or pop science, I've heard that caffeine works by inhibiting enzymes called phosphodiesterase, or by controlling the release of calcium within cells. Is that still the leading explanation?
Yes, those mechanisms have been discussed in the past. However, the sources we're looking at for this deep dive are quite definitive on this point. They state that while pharmacologically these mechanisms are possible, they consider them physiologically irrelevant when it comes to the typical effects seen after consuming coffee.
Irrelevant. That's a strong word for scientific mechanisms. Why do they dismiss them?
Because, they explain, the concentrations of caffeine required to significantly inhibit phosphodiesterase or cause meaningful changes in intracellular calcium release are much, much higher than what you actually achieve in the body after drinking a typical cup or even several cups of coffee.
Ah, okay. The dose isn't high enough in reality.
Exactly. It's like needing a whole bucket of caffeine to trigger those specific pathways, but your blood only gets a few drops relative to that threshold. The concentrations achieved are just too low in living organisms to be the primary drivers of coffee's effects at typical consumption levels.
Got it. So if it's not those, what is the primary physiologically relevant mechanism by which caffeine acts in the body, according to these sources?
The only known physiologically relevant mechanism they highlight is the antagonism of adenosine receptors.
Okay.
Caffeine acts as a blockader and antagonist at these receptors.
Adenosine receptors. Can you paint a picture of what adenosine does normally and how caffeine interferes?
Yeah, sure. Think of adenosine as a signaling molecule your body produces naturally. It builds up throughout the day.
Right. Makes you feel tired.
Exactly. And binds to specific receptors on cells, essentially signaling fatigue and promoting relaxation or decreased activity in certain areas. There are several subtypes of adenosine receptors, but the sources focus on two main ones in relation to caffeine: inhibitory A1 receptors and facilitatory A2A receptors.
A1 and A2A.
And adenosine constantly, or tonically, activates these receptors at a baseline level.
And caffeine blocks this baseline activity.
Exactly. Caffeine fits into the receptor site where adenosine would normally bind, but it doesn't activate the receptor. It just sits there, blocking adenosine from doing its job.
Okay.
Now, this is key. The effects you experience depend on which receptors are predominantly blocked and whether you consume coffee just once, acutely or regularly chronically.
Okay, acute versus chronic consumption. That distinction seems crucial for understanding coffee's effects, particularly for long-term health.
It truly is. The acute effects, that feeling of increased alertness, attention, faster reaction times, improved physical and mental performance, what we call the psychostimulant effect, are primarily a result of caffeine counteracting adenosine A1 receptor activation.
The A1 receptors?
Yeah, A1 receptors are particularly abundant in the brain. By blocking A1, caffeine just inhibits neurons, leading to that feeling of wakefulness and mental sharpness.
That makes perfect sense for the morning jolt. But what about the effects of regular daily coffee consumption over months and years?
This is where the sources present a fascinating idea. They suggest the impact of chronic consumption shifts focus. It's attributed more to controlling adenosine A2A receptor-mediated effects.
A2A this time?
Right. A2A receptors play a role in adaptive responses and can, if overstimulated by adenosine, contribute to transitions toward abnormal or dysfunctional cellular states. By regularly blocking A2A receptors with moderate coffee intake, caffeine seems to counteract potentially misadaptive responses and help prevent that slide towards cellular and tissue dysfunction associated with aging.
Preventing dysfunction. Stabilizing things. That strongly aligns with the idea of maintaining health span, doesn't it?
It does. The sources propose that regular, moderate coffee intake essentially helps maintain functional normalization and stabilization across various systems in the body.
Functional normalization.
Yeah. This leads them to suggest that for regular consumers, maybe we should rethink calling caffeine just a psychostimulant. Perhaps a more accurate term, given these long-term effects, would be a normalizer.
A normalizer. Wow, that totally reframes how I think about my morning coffee. It suggests the long-term subtle effects on preventing cellular decline might be more relevant for healthy aging than the short-term buzz.
That's a really good way to put it.
And maybe this helps explain the J or U-shaped curve we often see in studies. Moderate intake is normalizing, but excessive intake pushes things too far beyond stabilization and introduces negative effects.
That's a very insightful interpretation based on the evidence presented. And while caffeine is this dominant player, it's vital to remember, as we touched on, that coffee isn't a single uniform substance.
Right, right.
The way it's grown, processed, and brewed dramatically alters the precise mix and concentration of all those potentially bioactive compounds, including the ones we just discussed.
Right, so not all coffee is created equal. What factors really change the chemical profile of what ends up in your cup?
The sources highlight several. First, the agricultural factors.
Right.
The species of coffee bean. The two main ones are Arabica and Robusta.
Arabica and Robusta, okay.
Robusta beans, for example, naturally contain about 1.5 times more caffeine than Arabica and also higher levels of chlorogenic acids.
More caffeine, more CGAs.
But they have lower trigonylane and significantly lower levels of the diterpene in Caldwell.
So the bean itself is the first difference.
Exactly. Then there's processing. Roasting levels change the chemistry affecting CGAs and forming melanoidins, for instance.
Light roast versus dark roast matters.
Definitely. Different types of processed coffee, like instant ground, espresso blends, or filter roasts, have different characteristics. The sources note there's a lack of really comprehensive data on the specific impact of processes like freeze drying or spray drying on the levels of all the different bioactives.
Okay, so processing is another big one. And then there's what happens in our own kitchens. How we brew it matters.
Hugely. The water-to-coffee ratio, the temperature of the water, and how long the water is in contact with the coffee grounds the brew time, all influence how many of those water-soluble compounds, like CGAs and caffeine, are extracted. Methods using high pressure and temperature, like making espresso, are very efficient at pulling out those soluble components quickly.
Right. Espresso is fast and intense. What about methods where the coffee is boiled, like traditional Turkish coffee or using a French press?
Boiling coffee tends to extract higher levels of diterpenes, and this leads to a critical distinction the sources emphasize, one with real practical implications for your health.
All right, what's that?
If that boiled coffee brew is unfiltered, meaning the grounds remain in contact with the liquid, or only partially filtered, like in a traditional French press, before pressing, or if the filter isn't fine enough,
Right.
you end up with significantly higher levels of diterpenes, specifically cafestol and Caldwell, compared to filtered coffee. Methods using paper filters, like drip coffee, remove most of these diterpenes.
That's a crucial detail. So, my French press habit might expose me to something different than a drip coffee habit. A lot different, maybe.
Precisely. The type of bean and how you prepare it can fundamentally alter the compound profile, which logically could lead to varied health effects. This variability also presents a significant challenge for researchers trying to compare studies where participants might be drinking very different kinds of coffee.
I can see how that complicates things. Before we look at the big picture, is there anything else the sources mention about potential downsides related to processing? I often hear concerns about acrylamide in coffee.
The sources do briefly touch on acrylamide. This is a chemical compound that forms naturally during high-temperature cooking processes, and coffee roasting is one of them.
Okay.
They note that instant coffee tends to have higher levels of acrylamide than espresso or filtered coffee, likely due to the processing methods involved.
And isn't acrylamide considered potentially harmful?
In animal studies, acrylamide has shown neurotoxic and carcinogenic effects. However, the sources are careful to state that human epidemiological studies looking at dietary acrylamide exposure generally show a lack of association with cancer incidence.
Ah, okay, so the human data isn't as clear-cut.
Right. They also mentioned that international bodies like the WHO and FAO acknowledge the potential risks but agree that more research is needed, and specifically for cardiometabolic effects from dietary acrylamide, the sources state the impact remains inconclusive.
Okay, so while it's present and concerning in animal models, the human data linking it directly to major health issues from coffee seems mixed or not strongly established, at least according to the sources. That provides important context. All right, we've dissected the coffee bean and how it's prepared. Now let's zoom out and look at the most fundamental outcome, living longer. What do these sources conclude about coffee's overall impact on mortality?
This is where the evidence is quite compelling, and across numerous studies, remarkably consistent. The overall consensus from many large meta-analyses and prospective cohort studies conducted across diverse populations in Europe, the Americas, and Asia strongly suggests that regular consumption of moderate doses of coffee is associated with a significant impact on overall longevity.
So it's linked to people living longer lives. By how much? Based on the numbers in the sources.
Well, the sources are risk ratios for all-cause mortality, ranging generally between 0.78 and 0.94.
Okay, so that's like a 6 to 22% lower risk.
Exactly. This means, statistically speaking, regular moderate coffee drinkers were estimated to have that lower likeliness of dying during the study follow-up periods compared to non-coffee drinkers. They even cite estimates using specific methods that attribute a gain of about 1.84 years of life expectancy, or between 4.7% and 9.1% of estimated years of life to coffee intake.
Those are substantial effects for a daily habit enjoyed by billions. Is there a point of diminishing returns, or is more coffee always better for longevity?
Definitely not more is always better. The sources consistently describe the relationship between coffee dose and lifespan benefits as a J-shaped or U-shaped curve.
J or U-shaped, right.
You see noticeable benefits even with just around 1 cup per day. The maximum benefits are typically observed at moderate consumption levels, commonly cited as being around 2, 3, or 3, 4 cups per day.
The sweet spot.
That seems to be it. But beyond that, as intake increases usually above 5 or 6 cups per day, the additional benefits start to diminish, and in some studies the risk begins to tick back up towards that of non-drinkers.
Why that drop-off at higher doses? What happens when you drink too much?
The sources directly connect the waning benefits at very high doses to the increased likelihood of experiencing negative effects associated with excessive caffeine intake, sometimes referred to as a caffeineism syndrome.
Caffeineism, okay.
These include well-known symptoms like anxiety, nervousness, agitation, restlessness, sleep disturbances, tremors, and gastric discomfort. While perhaps less reported as severely in older adults compared to younger individuals, these adverse effects at high levels could counteract the potential benefits on longevity and health.
So the J or U shape makes physiological sense. Moderate intake offers normalization and benefit, but pushing it too far introduces negative effects that erode that gain.
Exactly. And it's worth noting that many of these large studies carefully adjust for other lifestyle factors that could influence mortality. For example, the protective effect of coffee on overall mortality was found to be stronger in non-smokers compared to smokers.
Makes sense.
Similarly, when studies stratified by alcohol intake, the coffee benefit was more apparent or robust.
That makes sense. Smoking and heavy alcohol consumption are such strong risk factors that they could easily overshadow or confound any protective effect from coffee.
Right. And as a practical point for you, the listener, the sources also briefly mentioned that adding significant amounts of sugar, flavored syrups, or large quantities of cream or milk to your coffee is also expected to offset some of the potential health benefits compared to consuming plain black coffee.
The additions matter too. Good point.
It's another layer of complexity in translating the population data to individual habits.
Okay, so the overall picture for longevity is quite positive, especially in that moderate range after accounting for other habits. But as we discussed at the start with the longevity trap, it's not just about living longer. It's about preserving health span, avoiding those debilitating chronic diseases. How does coffee consumption relate to specific age-associated conditions?
Let's dive into the details the sources provide on that. They cover several key areas.
Starting with perhaps the most concerning for many people as they age: brain health. Cognition, memory, dementia, and Alzheimer's disease.
Right. Memory deterioration is a very common part of aging, and the incidence of dementia, including Alzheimer's, rises exponentially after the age of 65. Several meta-analyses reviewed by the sources, though they note not all of them,
Okay, so some disagreement.
do report an inverse association between regular coffee consumption and the risk of developing dementia and Alzheimer's disease.
Is the link very strong? How big is the effect?
The sources describe the overall association based on pooled data as rather modest. And similar to overall mortality, the association with incident cognitive disorders is often described as J-shaped,
That J shape again.
with the maximal apparent benefit occurring at moderate consumption levels, typically around 2–3 cups per day.
Are there specific groups or patterns of consumption where the brain benefits are most noticeable?
This is where it gets particularly interesting. The sources highlight findings suggesting that regular coffee consumption in community-based samples of older adults, specifically those aged 80 years or more, seems related to the preservation of cognitive function.
80 plus, okay.
This effect was noted as being particularly evident in individuals who are identified as morning types.
Morning types, like chronotype. That's a fascinating detail. What about changing coffee habits later in life? Does starting or stopping make a difference?
This is a key nuance the sources emphasize and is perhaps counterintuitive. They point to research showing that increasing coffee consumption in older individuals who are currently cognitively normal was associated with an increased rate of developing mild cognitive impairment, MCI.
Wait, increasing intake was bad.
In that specific context, yes. In contrast, maintaining a constant moderate level of coffee consumption was associated with a reduced rate of developing MCI.
Wow. So consistent moderate intakes seems helpful for older adults' brains, but suddenly drinking more might be detrimental. That's vital information. Is this brain effect mostly due to caffeine or other compounds?
The sources strongly suggest the benefits seen in aged individuals are particularly related to caffeine intake or levels in the body.
Caffeine again.
Yeah. They cite studies where caffeinated coffee was associated with cognitive performance benefits in older adults, while decaffeinated coffee was not. This leads them to propose that caffeine may have a more pronounced beneficial effect on cognition in older adults compared to younger individuals.
So caffeine seems like the key player for late-life cognition based on this. What do the sources suggest about the underlying mechanisms? How might caffeine help the aging brain?
They discuss several possibilities. Higher coffee consumption has been associated with a slower accumulation of beta-amyloid peptides in the brain.
The Alzheimer's plaques.
Exactly, which are hallmark features and thought to be involved in the development of Alzheimer's disease. They note that theobromine, a metabolite of caffeine, also correlates with beta-amyloid levels.
Interesting.
In laboratory studies using cell lines, coffee extracts, caffeine, and other methylxanthine compounds structurally related to caffeine have been shown to decrease the production and aggregation of both beta-amyloid and tau proteins. Tau is another type of protein implicated in Alzheimer's pathology.
And the adenosine receptors come up again here. I bet they do.
Yes, absolutely. Genetic variations, or polymorphisms, in the adenosine A2A receptor, caffeine's main target, are linked to the risk of developing Alzheimer's disease and variations in the size of the hippocampus, a brain region crucial for memory.
Okay.
Furthermore, how quickly an individual metabolizes caffeine, which is largely determined by variations in the CYP1A2 enzyme.
The caffeine metabolism gene.
Right, a type of cytochrome P450 enzyme, also appears to influence the relationship between coffee consumption and dementia risk.
So genetics influencing both the target and the breakdown of caffeine could determine how protective coffee is for your brain as you age. Are there other compounds in coffee that might help the brain?
The sources briefly mentioned that chlorogenic acids, the polyphenols, might also contribute to age-associated memory preservation, as polyphenols in general have been linked to improved memory performance in the elderly.
Okay, so some promising leads and mechanisms, but the overall effect is described as modest, and there's heterogeneity in the studies, some conflicting findings too.
Correct. And highlighting clear long-term effects from coffee consumed decades earlier on memory later in life is inherently difficult in observational studies. They also point to some conflicting findings from other research groups, which sometimes report opposite associations, possibly linked to specific types of brain pathology like Lewy bodies deposition.
Okay.
So it's a complex picture, but the association, particularly for moderate, consistent intake in older adults, is noteworthy.
Let's shift to mood and mental well-being. Depression is a significant issue, especially for older adults, and can severely impact health span.
It is, and it's often under-recognized in the elderly population. The good news here, according to multiple meta-analyses cited, is that regular coffee and dietary caffeine intake consistently show a protective effect against the development of depression.
Protective? How much?
Individuals with higher coffee intake were found to be approximately 25% less likely to experience depression.
25%, that's quite significant. Is there a dose sweet spot for mood as well?
Yes. Studies like the large UK Biobank cohort mentioned in the sources found a J-shaped association for both depression and anxiety risk,
J-shape again? Predictable now?
with the lowest risk levels observed again at around 2-3 cups per day.
Okay, 2-3 cups. We often reach for coffee when we're feeling stressed. Does it actually help with stress?
That's a fascinating area discussed in the sources, because the findings are a bit complex, maybe even contradictory.
Oh, how so?
They note that coffee intake does tend to increase under stressful conditions, suggesting people instinctively seek it out.
Yeah, I do that.
They cite studies where coffee consumption triggered an increase in salivary alpha amylase, a marker often associated with stress response, but crucially, without a simultaneous increase in cortisol, which is the primary stress hormone.
So one stress marker up, but not the main hormone.
Right. This pattern might suggest some kind of anti-stress property or a modulation of the typical stress response. But they immediately contrast this with other evidence showing that coffee or caffeine exposure is associated with increased levels of plasma cortisol, which is what you would expect if it were sustaining or even increasing stress responses. Host, speaker.
So the direct physiological effect on stress hormones seems contradictory based on the sources. One marker up without cortisol, but other studies show cortisol is up. It appears so in the evidence presented. It's an area that clearly needs more clarity. However, when focusing specifically on mood and the protective effect against depression, caffeinated coffee consistently showed a more robust positive effect compared to decaffeinated coffee, even decaf with added chlorogenic acids.
So caffeine seems key for the mood benefit, regardless of the stress hormone confusion.
That strongly implies caffeine is the primary compound driving the mood benefit.
And is the adenosine receptor mechanism relevant to mood too?
Yes. Genetic variations, polymorphisms in the adenosine A2A receptor are also linked to susceptibility to depression and panic disorders.
And it's notable that istradfiline, a drug that is an A2A receptor antagonist like caffeine, but much more specific and potent, currently used to treat Parkinson's disease symptoms, has also shown beneficial effects on mood. Wow. This adds further weight to the idea that caffeine's action on A2A receptors might be relevant to its mood effects.
That's a powerful connection. And what's the most severe outcome linked to depression?
Suicide, sadly, and the incidence is higher in older adults than in younger populations.
Well,
The sources report findings that moderate caffeine intake is associated with a significant reduction in both suicide ideation and the actual number of deaths attributed to suicide.
that's huge.
Lower plasma caffeine levels were also found to be linked to significantly higher odds of experiencing major depressive disorder.
Those are profound potential benefits for mental well-being and preventing a tragic outcome. What about physical function? Frailty is a major concern for maintaining independence as we age.
The sources note an association between coffee consumption and a reduced risk of physical frailty in late life.
Reduced frailty, too.
Yes. This is another piece of the puzzle suggesting coffee might help preserve functional capacity and independence as people age, adding another dimension to the health span benefit.
Any surprising links the sources uncovered? Anything unexpected?
Perhaps respiratory health? Respiratory diseases are a major cause of death, particularly in Europe. The sources cite studies that have concluded coffee consumption was inversely associated with mortality, specifically from respiratory diseases.
Respiratory diseases, that's not an intuitive connection for coffee. It really underscores how broadly coffee's complex mix of compounds might be acting across different systems in the body.
It does. Moving on to metabolic health, the sources highlight a strong and very consistent link here, especially regarding two widespread conditions.
Type 2 diabetes and issues with blood lipids like cholesterol.
Exactly. Regular coffee intake is strongly linked to a robust preventive effect against the development of type 2 diabetes.
That's a big one.
It is. Furthermore, it's associated with protection against dyslipidemia, which is an abnormal level of lipids or lipoproteins in the blood, including high cholesterol. The sources present this as a compelling point for coffee's potential role in preventing metabolic dysfunction, which is a common feature of aging.
So coffee is good for cholesterol. Seems simple enough.
Here's where, as we mentioned earlier, the nuance is absolutely critical, and it depends entirely on how you prepare your coffee.
Right, the filter thing.
Exactly.
Yeah.
While there's a general association with protection against dyslipidemia overall, other evidence strongly suggests that long-term heavy consumption of coffee is associated with increased levels of LDL cholesterol, the bad cholesterol, apolipoprotein B, ApoB, and total cholesterol.
Just LDL. Okay, so not purely good then.
And the sources are very clear on why this happens.
Remind me, what's the key factor, the deterpenes?
It's the brewing method. The sources explicitly state that coffee prepared by boiling, such as traditional Turkish coffee or French press methods if they are unfiltered, contains significant levels of diterpenes, specifically caffeine and kawil.
Right.
These diterpenes are well established to increase serum cholesterol levels. Conversely, filtering coffee, using a paper filter as in drip coffee makers, effectively removes most of these cholesterol-raising diterpenes.
That is a hugely important practical takeaway. So if you drink unfiltered boiled coffee regularly, like French press without a paper filter, you might be raising your LDL cholesterol, even while potentially gaining other metabolic benefits like diabetes prevention from the moderate coffee itself.
Precisely. It's a perfect illustration of how the preparation method dramatically impacts the health effects, sometimes in opposing directions for different outcomes.
Fascinating. Now, drilling down into how coffee might exert these metabolic effects at a cellular level, the sources discuss proposed mechanisms. What are they finding?
They suggest coffee components can modify the activity of key metabolic regulators within cells, such as AMPK and sirtuins.
AMPK and sirtuins. Okay, these come up a lot in aging research.
They do. Think of AMPK as a cellular energy sensor and master switch that gets activated when energy levels are low or stress is high. It's associated with promoting cellular health and is linked to cellular aging.
Right.
Sirtuins are a family of proteins, often called longevity proteins, because they play roles in managing cellular stress, energy metabolism, DNA repair, and the aging process.
Okay, cellular energy and stress managers.
Yeah.
What evidence do the sources present for coffee affecting these?
Well, they cite findings in lab studies, for example, showing that coffee extract increased the activity of CPT1, an enzyme involved in fat burning in liver cells mediated through AMPK activation.
Okay.
It also increased glucose uptake in these cells.
Yeah.
Extract from Robusta coffee silverskin was shown to alter the activity of AMPK, sirtuin-1, and MTOR.
MTOR, another big aging pathway.
Yeah, exactly. Another major cellular growth and metabolism regulator. They note that individual coffee compounds like caffeine and chlorogenic acids can control lipid accumulation, also often via AMPK pathways.
Right.
Notably, chlorogenic acid is shown to synergize with metformin, a widely used diabetes drug that is also being explored for its potential anti-aging properties.
Synergy with metformin, that's really interesting.
Yeah. CGAs promote AMPK phosphorylation, which is how it gets activated. Caffeine also activates AMPK, which is important for various cell functions, including enhancing endothelial cell migration, crucial for blood vessel health.
And how does coffee relate to sirtuins?
Studies in healthy human volunteers showed that daily coffee consumption increased serum levels of sirtuin-1.
Increased sirtuin-1 in people.
Okay, in cellular models, chlorogenic acids have been shown to recruit sirtuin-1 to help prevent lipotoxicity damage caused by excess fat accumulation in cells. And caffeine itself has been shown to activate sirtuin-1 and combine to and activate sirtuin-3, which is found in the mitochondria and plays a role in energy metabolism and cellular stress response.
So coffee components seem to be interacting with these fundamental cellular pathways linked to energy, stress, metabolism, and aging. It's hitting multiple targets.
That's the hypothesis presented in the sources. They suggest these cellular effects could underlie the observed benefits on metabolic health and potentially aging itself. However,
Always a however.
they are careful to add that while this cellular level evidence is compelling, the specific hypothesis that coffee components like caffeine or CGAs actually restore metabolic dysfunction in aging via pathways like AMPK and sirtuins still needs to be rigorously tested experimentally in aging cells and, most importantly, in aged individuals.
That makes sense. Lab findings are promising, but need to be confirmed in the context of real human aging. Let's talk directly about cardiovascular health, heart disease, and stroke.
Right. This is an area where the relationship with coffee is described as complex and somewhat mixed depending on the specific cardiovascular outcome being studied.
Makes sense.
For overall cardiovascular disease, CVD, or coronary heart disease, CHD, the findings in studies are somewhat mixed. For heart failure specifically, there seems to be a J-shaped relationship, much like with overall mortality.
Moderate benefit, higher risk, maybe at extremes?
Potentially.
Yeah.
Some benefit at moderate intake, but potentially higher risk at very high intake, like over 6 cups a day in one UK biobank study mentioned. Though other meta-analyses didn't find increased risk at a median of 5 cups per day, so again, highlighting differing findings.
Okay. What about things like irregular heartbeat, atrial fibrillation?
Atrial fibrillation also shows mixed associations with coffee intake in different studies. Not a clear picture there either.
And blood pressure, that's a common question people have about coffee. Does it raise it?
This is perhaps one of the most nuanced areas, with information presented in the sources that requires careful, impartial reporting as it reflects the complexity of the research.
Okay, lay it on us.
Most evidence across a wide range of studies suggests that while coffee consumption causes a short-term increase in blood pressure,
The immediate spike.
right, that feeling right after you drink it,
Yeah.
but it appears to have no significant effect on long-term blood pressure levels and does not increase the overall risk of developing sustained hypertension over time.
No long-term risk generally?
One source summary even mentions a weak association between moderate to high coffee intake, defined in that case as 2 to 8 cups per day, and a decreased risk of hypertension.
Okay, so generally not a long-term risk for most people, maybe even slightly protective according to one viewpoint. But I sense there's another side. You mentioned complexity.
Yes, one of the source reviews explicitly states immediately after discussing the lack of long-term risk for the general population that pre-hypertensive and hypertensive populations.
People who already have high blood pressure.
Exactly. They may experience more pronounced acute blood pressure increases even at lower caffeine doses, up to 400 milligrams, which is roughly 4 to 5 cups depending on strength.
Okay.
Furthermore, this review suggests these groups could potentially have a small increased risk of sustained hypertension with regular consumption.
Ah, so for people already with high BP, the story might be different, maybe riskier.
It might be. There isn't a uniform consensus across all research presented for this specific group. We just report what the sources say, which indicates complexity and potential differences based on pre-existing health status.
Absolutely, just presenting the nuanced findings as they appear in the sources. What are the proposed mechanisms for these blood pressure effects, both the acute rise and potential long-term lack of effect or benefit?
For the acute rise in blood pressure right after drinking coffee, proposed mechanisms include activation of the sympathetic nervous system, our fight or flight response,
Makes sense.
antagonism of adenosine receptors, which normally help relax blood vessels, increased release of norepinephrine, effects on kidney function, and influences on the renin-angiotensin system, which regulates blood pressure and fluid balance.
Okay, several potential factors for the spike.
And for potential long-term favorable effects on the cardiovascular system, mechanisms include enhanced endothelium-dependent vasodilation, the ability of the inner lining of blood vessels to relax and widen,
Better blood vessel function.
and general improvements in endothelial function and arterial stiffness. So it's a mix of potentially acute negative effects on BP, balanced by possible long-term positive effects on vascular health.
Complex indeed. Moving on to cancer risk, historically, coffee was sometimes listed as a potential carcinogen, wasn't it?
It was. But the sources highlight a major shift in scientific consensus over the years. In 2016, the International Agency for Research on Cancer, IARC, reclassified coffee.
What did they change it to?
It was moved from Group 2B, possibly carcinogenic to humans, to Group 3, unclassifiable as to carcinogenicity in humans.
Unclassifiable, so not enough evidence either way.
That's the official stance. However, one source notes that, in their opinion, this Group 3 classification is still disputable at best, given the evidence that has accumulated since then.
Oh, so what does that accumulating evidence suggest? Maybe not so unclassifiable.
It points towards an inverse association, meaning a potentially decreased risk with some types of cancer.
Okay, decreased risk for some cancers. Which ones?
The sources specifically mention hepatocellular cancer, liver cancer, melanoma, a type of skin cancer, and colorectal cancer as having the strongest evidence for an inverse association with moderate coffee consumption.
Liver, skin, colorectal. Got it.
Some studies also suggest a possible decreased risk for cancers of the oral cavity and pharynx, kidney cancer, and advanced prostate cancer.
So it might be protective against some cancers.
The sources are careful to state that the data overall remains mixed. While there's accumulating evidence for protection against certain specific cancer types, this is not a definitive protective effect across all cancers, and findings vary depending on the cancer site and study.
Okay, clearly the relationship between coffee and cancer is much more nuanced than previously thought, moving away from being a blanket risk factor to potentially being protective against some forms, while the overall picture is still complex, not a simple yes or no.
Absolutely. Now let's take our deep dive even deeper, moving beyond organs and systems to the fundamental biological processes happening within our cells that are affected by aging.
Down to the cellular level.
Right. The sources explore how coffee components might intervene at this microscopic level, drawing largely on findings from laboratory studies or studies conducted in younger populations.
Let's start with our genetic material, our DNA. Aging is associated with increasing genomic instability due to accumulated DNA damage. Does coffee help or hurt here?
That's right. Our cells are constantly bombarded by damaging agents, and their ability to repair that damage declines with age. The sources present findings from several intervention studies, predominantly conducted in young, healthy volunteers.
Young people, okay. What did they find?
For example, studies showed that moderate consumption of coffee or even cocoa with caffeine decreased plasma markers of DNA damage. Another study found that drinking 750 milliliters of fresh coffee daily for 4 weeks decreased spontaneous DNA strand breaks in blood cells by a significant 27%.
27% reduction in DNA breaks. That's impressive.
It is. Instant coffee also showed similar protective effects on strand breaks in lymphocytes, a type of white blood cell. Coffee consumption was also found to protect lymphocyte DNA from damage caused by exposure to genotoxic compounds in a lab setting.
That sounds very promising, coffee helping to protect our cellular blueprints. Is there any point where coffee might increase DNA damage? Too much of a good thing.
Yes, and this reinforces the importance of dose, that U-shaped curve idea again.
Right.
The sources contrast the protective findings with one study that found heavier coffee consumption, defined in that particular study as more than 3 cups per day, was associated with increased sperm DNA damage, specifically damage associated with double-strand breaks.
So more than 3 cups hurt sperm DNA in that study.
It seems the protective effect seen at moderate levels seems to be lost or even reversed at high caffeine levels, as caffeine itself can be genotoxic damaging to DNA at very high concentrations.
So yet another instance where dose is key protection at moderate levels, potential harm at excessive levels.
Exactly. And the sources are careful to add the crucial limitation that most of this evidence comes from studies in young adults or laboratory settings.
Not older adults.
Right. They highlight a study using a human skin model showing caffeine counteracting a DNA damage marker, but stress that this appears to be the only study they reviewed, specifically investigating a potential protective effect related to aging itself.
Only one study related to aging.
Apparently so, in this specific context of DNA damage. This underscores the clear need for more studies directly in elderly volunteers to confirm if these protective effects on DNA stability hold true as we age.
Good point. Lab findings are a starting point, but the real test is in aged humans. What about inflammation and oxidative stress, which are known contributors to aging and disease? Inflammaging.
Yes, aging is strongly associated with a chronic, low-grade inflammatory state, often termed inflammaging, and increased oxidative stress damage from unstable molecules called free radicals. The sources remind us that several coffee components, like melanoidins and chlorogenic acids, possess documented anti-inflammatory and antioxidant properties.
Does the research support that coffee reduces these in the body? In people?
Yes. Meta-analyses of human studies have linked coffee consumption to decreased levels of circulating inflammation markers, such as C-reactive protein, CRP.
Lower CRP. Okay.
At a cellular level, as we touched on earlier with CGAs, chlorogenic acid has been shown to inhibit inflammatory pathways, like TLR4-mediated NFP signaling. Caffeine itself has been shown to inhibit the activation of the NLRP3 inflammasome,
The inflammasome, right?
a key protein complex in cells that triggers inflammatory responses via specific signaling pathways. In vitro studies also show caffeine preventing inflammation in cell cultures.
So caffeine can calm down that inflammatory trigger.
Seems like it. The sources also mention that antioxidant flavonoids present in coffee, such as camphorol and quercetin, contribute to mitigating oxidative stress, which is linked to conditions like diabetes. In vitro studies show coffee extracts providing protection against oxidation induced by hydrogen peroxide, a common oxidant.
So coffee contains compounds that seem to directly interfere with key cellular pathways that drive chronic inflammation and oxidative damage, processes fundamental to aging.
That's right. And the analysis here is that by reducing chronic inflammation and oxidative stress, coffee could plausibly contribute to the broader health benefits observed with aging, including those effects on cardiometabolic health.
Let's move on to protein health and cellular cleanup. Our bodies constantly make, fold, and break down proteins, a process called proteostasis. I know that breaks down as we age, leading to buildup of junk.
Proteostasis is vital for maintaining the function of our cells and tissues. When this system falters with age, misfolded or damaged proteins can accumulate, contributing to many age-related diseases, including neurodegenerative disorders like Alzheimer's and Parkinson's, muscle loss, and even cardiovascular issues.
Right.
A key part of proteostasis is autophagy.
Autophagy, that's the cellular self-cleaning process, right?
Yeah.
Getting rid of damaged components, like
Well,
taking out the trash.
exactly. Autophagy is how cells clear out damaged proteins, organelles like mitochondria and other debris. It's a critical process that declines with age, and inhibiting it is linked to cellular senescence.
Those are zombie cells.
When cells stop dividing but don't die, contributing to aging and premature aging phenotypes. Conversely, activating autophagy can inhibit senescence and potentially improve health span.
How does coffee or its components relate to autophagy? Can it boost this cleanup?
There's accumulating evidence from various studies, including cell cultures and animal models, suggesting that regular coffee intake or chronic exposure to moderate caffeine levels can activate autophagy flux.
Activate it. How?
One proposed mechanism is via the inhibition of mTOR signaling. mTOR is a major cellular hub that regulates cell growth, metabolism, and proliferation. It typically inhibits autophagy, so inhibiting mTOR can promote cleanup.
Okay, so coffee might turn down mTOR, letting autophagy run. Is there evidence for this happening at realistic coffee consumption levels? Or is it just megadoses in labs?
That's a key question. Some earlier studies showing coffee caffeine activating autophagy use very high concentrations that might not be achieved in the body with typical coffee drinking.
Right.
However, the sources highlight specific studies that used physiologically relevant concentrations of caffeine, for instance. Less than 10 micromolar in keratinocytes, a type of skin cell.
Realistic levels, then?
Yes. These studies show that caffeine, at these realistic levels, was able to suppress cellular senescence and activate autophagy. They traced this effect through a specific pathway.
What was the pathway?
It involved antagonism of the adenosine A2A receptor, which then activated sirtuin-3, which in turn activated AMPK.
Wow, so it links back to both the adenosine receptors and those key metabolic aging regulators, sirtuins, and AMPK. It's all connected.
Precisely. It suggests a potential chain of events where caffeine, acting on its primary target, can influence these fundamental cellular processes. They also mention another study using a topical extract from Coffea araba beans on human skin fibroblasts.
Skin cells again.
Right. Connective tissue cells. This extract was shown to bolster both the proteasome, another protein degradation system, and autophagy processes, leading to increased activity of these cleanup pathways and a reduction in the accumulation of damaged proteins and lipofuscin.
Lipofuscin, the age pigment, so less cellular junk.
Exactly. Bolstering cleanup and reducing age-related cellular junk, that sounds like it could directly combat the decline in proteostasis we see with aging.
It does. And the sources speculate that this ability to bolster protein turnover and cleanup might be the underlying mechanism behind an intriguing observation from one study.
What was that?
That regular consumption of moderate coffee was associated with a decrease in age-related changes in the profile of proteins found in plasma. And this change, in turn, was associated with a reduction in the predicted rate of biological aging.
That's powerful speculation that your coffee could be slowing down biological aging at a fundamental cellular level by improving protein cleanup.
It's a compelling hypothesis emerging from the research, but I'm guessing there are caveats.
Like many areas, the sources stress the need for consolidation. This evidence needs to be confirmed using physiological concentrations across more studies, testing different coffee types and regimens, and critically, directly monitoring these effects in elderly individuals.
Right, need studies in older people.
And the question remains whether the proteostasis and autophagy effects are primarily attributable to caffeine or require the synergy of other coffee components.
It sounds like there's a lot of exciting potential here with plausible mechanisms at the cellular level, but also a lot of complexity in areas where more research is needed, especially in older humans.
That leads us directly to the challenges inherent in studying something as ubiquitous and complex as coffee and its long-term health effects, challenges that the sources are very transparent about.
What are the main hurdles researchers face? Why is this so hard to study definitively?
One of the biggest is what they call the variability problem, which we touched on. Coffee consumption is not a single standardized variable in most studies.
Right, the type, the brew.
As we discussed, the actual composition of bioactive compounds varies dramatically based on factors like the coffee variety, Arabica versus Robusta, how it's processed, roasting, instant versus ground, and critically, how it's brewed, filtered versus unfiltered, water temperature, time, water to coffee ratio. This significant variability in what people are actually consuming is seldom fully captured or accounted for in large observational studies.
So comparing someone who reports 3 cups of coffee is almost meaningless without knowing what kind of beans, how they're processed, and exactly how they're brewed. A cup isn't just a cup.
Exactly. Another major challenge is study design. A vast amount of the evidence comes from epidemiological studies, which rely heavily on self-reported consumption via questionnaires.
Which can be unreliable.
Right. This data can be subject to recall bias, isn't always precise, and often doesn't distinguish between different types or preparation methods. Conducting gold standard, long-term controlled intervention studies for something as widely consumed and readily available as coffee is incredibly difficult and expensive.
Can't really do a double-blind trial with coffee easily.
Not easily. Furthermore, many of coffee's bioactive constituents are found in other foods, making it hard to isolate coffee's unique effects in controlled diets.
And we also saw how effects might vary depending on the person's genetics or pre-existing conditions. Like with caffeine metabolism and blood pressure, that must complicate things too.
That's another key limitation highlighted by the sources. They state that currently, researchers are unable to precisely define and easily identify individuals who might benefit the most from coffee consumption versus those who might be less sensitive or even experience negative effects.
We don't know who responds best.
This individual variability can stem from pharmacokinetic differences, how quickly and how effectively your body absorbs, distributes, metabolizes, and excretes coffee compounds, and pharmacodynamic differences, how your cellular targets and physiological systems actually respond to those compounds. Personal traits that predict whether someone will benefit or potentially be harmed need much more clarification.
So giving truly personalized advice, like you should drink this much of this kind of coffee based on current science, is still a way off. We're not there yet.
Precisely. The sources conclude by calling for future epidemiological studies to specifically tackle these challenges, better defining the personal traits, like genetics or metabolic profile, that predicts who benefits, clarifying optimal doses and schedules of intake for different outcomes, and gaining a clear understanding of potential side effects in diverse populations, taking into account individual variability.
Okay, that was a truly deep dive into a beverage most of us consume every day. Let's bring it back to where we started, the longevity trap.
We began by discussing the human desire to live longer and the reality that increased lifespan hasn't always translated into equivalent gains in health span, with chronic diseases eroding quality of life as we age.
And what this deep dive into the sources suggests is that regular consumption of coffee, particularly in the moderate range, is consistently associated with positive effects on overall longevity, contributing to a lower risk of all-cause mortality.
And crucially, it appears linked to preserving health span by potentially reducing the risk or delaying the onset of many of those major age-related diseases that contribute to the longevity trap. Respiratory diseases, certain types of cancer, dementia and cognitive decline, depression, physical frailty, and metabolic issues like type 2 diabetes and dyslipidemia.
With the big caveat about unfiltered coffee and cholesterol. Can't forget that one.
Absolutely. That's a critical caveat.
And beneath the surface, the sources provide compelling, though sometimes preliminary, evidence that coffee components might be influencing fundamental cellular processes affected by aging, like protecting our DNA from damage, fighting chronic inflammation and oxidative stress, and bolstering our cells' ability to clean up damaged proteins and organelles through autophagy.
It's certainly not a simple story, and it's definitely not a miracle cure. The effects are often described as modest, findings can be heterogeneous across studies, and the nuances are vital.
Right.
The type of coffee and how you prepare it matters significantly, especially the filtered versus unfiltered distinction regarding cholesterol-raising terpenes.
And the sweet spot for most of the observed benefits seems to lie firmly in that moderate range, generally cited as 2 to 5 cups per day, with potential downsides or waning benefits emerging at higher doses.
So what does this all mean for you, the listener, as you navigate your own aging process? Your daily coffee habit within that moderate range might be contributing much more to your long-term health span, helping you live not just longer, but potentially healthier and with greater independence than you might have realized. But understanding the nuances of dose, preparation method, and the reality of individual variability is absolutely key.
Which leaves us with a few provocative thoughts to ponder over your next cup. Given the complexity we've uncovered and the significant individual variability, should personalized coffee recommendations, perhaps based on factors like your genetics or pre-existing health conditions, be something we aim for in dietary advice for healthy aging in the future?
It's an interesting thought. Or How do we thoughtfully balance these potential health span benefits against other potential effects not deeply covered here, such as sleep disruption for some individuals, which is a common complaint,
Right, we didn't get much into sleep.
or the impact of adding significant amounts of sugar, syrups, or cream? Those definitely change the equation.
How can you take this deeper understanding of coffee's link to healthy aging and apply it thoughtfully to your own habits and lifestyle choices as you move through life? Something to consider.
Indeed. Thank you for joining us for this deep dive into the fascinating intersection of coffee and healthy aging.
We hope you feel a little more informed, a little more aware of the complexity, and perhaps have a renewed appreciation for your daily brew and its potential role in your health span journey.